Happy Thursday. Hopefully your quick checks went well on Wednesday. So we are continuing on with some systems of equations. However, we're going to take a step back, and instead of talking about systems, we need to fill in some of your knowledge with inequalities. Now, we have been solely talking about linear equations in this class. And linear equations look like what you have right over here. We have a simple y equals 1/2 x minus 3, and we all know how to graph that. I have a y-intercept of -3, so 1, 2, 3. And my slope is 1/2, so I'm going up 1 over 2. Up 1 over 2, up 1 over 2, and so on and so forth down this direction. And if you want to connect those, that line represents every single x and y pair of which this is true. That is a representation of all of the solutions of that graph. So we can sit down and look at these down below. We can say, hey, is 4, -1 a solution? Well, to figure out whether 4, -1 is a solution, we just need to look at our graph. 4, -1, 1, 2, 3, 4, -1. Sure enough, 4, -1 is on our line. So yes, this is a solution. It is on our line. Now if we look at this point, 2, 2, 2, 2, right 2, up 2, that is off. So this is not a solution. Not a solution. And finally, -1, -4, -1, -4, 1, 2, 3, 4. This is also not a solution. Now, there are very few differences between this and this. In fact, if you look at the equations, or if you look at what we've got going on here, we've got y equals 1/2 x minus 3. But over here, we have changed the sign. Instead of an equal sign, we have this sign. We have a greater than equal to sign. And that actually changes our graph significantly. And I'm going to go ahead and flip over to Desmos here, just to kind of illustrate what we've got going on here. So currently, we are looking at this inequality. We have y is greater than or equal to 1/2 x minus 3. And wow, you can kind of see that we have the exact same line here. We have our y-intercept of -3. We go up 1 over 2, up 1 over 2, up 1 over 2. However, since we now have that greater than sign, everything above this is shaded. Whereas if I were to just have that equal sign, we just have a plain line. However, we have greater than or equal to. We have everything shaded above, including that line. So if I were to flip-flop this, instead of greater than or equal to, let's try to predict what happens with less than or equal to. Less than or equal to. And sure enough, we are shaded below. Now, kind of a cool thing happens when we do not have the equal sign instead of less than or equal to or greater than or equal to. But we'll talk about that on the next page. But let's go ahead and fill this in on our notes. So our notes, let's go ahead and start this by the exact same line. Our exact same line, we have y is greater than or equal to 1/2 x minus 3. So 1/2 x minus 3, we're starting at -3. And then my slope is still up 1 over 2, up 1 over 2. And then you can go back in this direction as well. And here you go. Now I want to shade every value above this. Every value above this is a height that is greater than or equal to that line. Now, for you guys, you have a few different ways that you can shade. Please do not be that kid that sits there and shades in the whole thing with his pencil, wasting an entire thing of lead. Don't be that person. So if you have a highlighter, that is my preferred method. However, if you don't have a highlighter, I can show you guys how to do that too. But with a highlighter, that should be fairly easy. Just kind of start to shade in this direction. Shade what way you would like. You could do the exact same thing with a pen, but just kind of show in general what way. And you don't have to color the whole thing, just show what direction you're shading. So let's go ahead and look at our solutions here. First off, is 4, -1 a solution? Well, if I look here, 4, 1, 2, 3, 4, down 1. Sure enough, that is on my line. Yes, that is a solution. Is 2, 2 a solution? Well, in the previous one, 2, 2 was all the way up here, and that was not shaded. However, 2, 2 here, yes, that is a solution. That is a point that is above this line. Y is greater than or equal to this line. This height is greater than that line. However, is -1, -4 a solution? No, -1, -4 is below, so that is not a solution. Not a solution. So this is the direction that we are going. Instead of simply one line, we are essentially going to have an entire plane of solutions that we can choose from. All right, so flipping the page over to example 1, we kind of have a long thing that is just going to describe how we can use inequalities. Now, this one is a little bit silly in terms of why would you ever write an inequality for this, but just go with it. We're going to use this to kind of illustrate a basic example, and then we could extend that into a more complicated one in a little bit. So here's our scenario. We've got a fishing adventures company that rents small fishing boats to tourists for day-long fishing trips. And each boat can hold at most 8 passengers. So we have a limit, 8 passengers. That is the max that this could be. And this could be for adults and children. So first thing it asks us to do is write an inequality to represent the total number of passengers. Well, I'm not very creative of a person, so I'm going to go ahead and say let X be the number of adults. Let's say X is equal to adults. And we're going to say that Y is equal to the number of children. So we have X is adults and Y is children. I'm going to go ahead and use that kind of as my key. So X is adults, Y is children. So write an inequality to represent the total number of passengers. Well, I know that my adults plus my children have to be less than 8. Now, I'm going to go ahead and add one final thing. Could we be exactly 8? Yeah, we could be exactly 8. So I'm going to go ahead and include that equal sign. So if I add up my adults and children, it has to be less than or equal to 8. All right, now another constraint that we have. Each boat can carry 1,000 pounds of people and gear for safety reasons. Assume an average adult weighs 150 pounds and an average child weighs 75 pounds. Also assume that each person will require 10 pounds of gear. All right, so write an inequality to represent and illustrates the weight limit on the boat. Well, I know that my boat limit is 1,000 pounds, so my total weight has to be there. Now, I know it would be really tempting to write 150x plus 75y has to be less than that. However, we have something else to take into consideration. Each one of those needs to carry about 10 pounds of gear. So my adults, my X, they're not just 150 pounds. They need to take into consideration 160 pounds. All right, an average child weighs 75 pounds, but remember they have to do the 10 pounds of gear. So that'll be 95 Y. And this needs to be less than or equal to 1,000 pounds. All right, so that is where we are at. We have 2 separate inequalities, one with our total number of people and the other one with our weight limit. So here's what I would like for you guys to do. Mr. Parsons is going to pause the video here in a moment, but Group A has 4 adults and 2 children. Group B has 3 adults, 5 children. Group C has 8 adults. And finally, Group D has 7 children and 2 adults. What I would like for you to do is I'd like for you to determine which of these groups can fit in one boat. So which of these groups, it could be more than one, it could be one, it could be all of them. But go ahead and either by yourself or with a partner, go ahead and determine which of these could be in a boat. So Mr. Parsons, go ahead and pause the video now. All right, let's go ahead and check your answers here. So Group A has 4 adults, 2 children. I went ahead and grabbed this for you so you can kind of visualize this. 4 adults was my X, 2 children was my Y. So right now, this is my number of people, and certainly that falls under this restraint. Let's go ahead and look at weight. If I look at my weights, Yep, sure enough, that falls in the shaded area there. So group A should have been circled. Group A does fit in our restraints. All right, group B, let's go ahead and fix this up. Group B is 3 adults and 5 children. We're kind of pushing it here. It is right on the bubble. We got 8 people. Let's check our weight limit. And sure enough, it is right inside of our weight limit. So group B could also go. All right, group C, 8 adults. All right, it's looking at group C, 8 adults, 8, 0. We have, obviously, room in the boat for them, but let's go ahead and check the weight limit. Ooh, it is too heavy there in terms of our weight limit. So those 8 adults, that is going to be too much. And then last group, well, this one should have been a fairly easy one. This one had 7 children and 2 adults. We got too many kids in the boat. I don't even need to bother about the weight limit. Because it is already above the number of people. So here is your solution. You should have had yes for group A, yes for group B, no for C and D. All right, now we're going to go ahead and get to graphing. So here we go. Graphing linear quantities. These only have one variable here. We have x plus 1 is greater than -2, and negative 4y is less than 8. So let's go ahead and look at this first one. If I subtract 1 from both sides, I'm left with this statement, x is less than -3. So in this one, I want to shade everything that has an x value that is less than -3. Now, my x's or -3s are right here. All right, now I'm going to do something interesting. I don't want to include all of these values because I want strictly x's that are greater than -3. So in this one, since we do not have the equal sign underneath it, I'm just going to make a dashed line there. I don't want to include ones that are equal to -3. I just want to include the ones that are bigger than that. So x is greater than -3, and greater, where are my bigger x values? Those are on the right. So I'm going to go ahead and go in this direction. Or you could do that with a highlighter. It does not matter. So when I solved this, I had x plus 1 is greater than -2. I subtracted 1. I need to shade in every x value that is greater than -3. And then finally, I shaded that in. So one possible solution, I'm going to go ahead and just choose something randomly over here. One possible solution is this one right here. 1, 2, 3, 1, 2, 3, 4. All right? 3, 4 is a possible solution that is in my shaded region. All right, over here, let's go ahead and solve for y. If I divide by -4, divide by -4. Well, you guys should have learned this in 8th grade, I believe, but I'll go ahead and give a refresher. Whenever you divide or multiply by a negative number, you need to flip that inequality. And it's kind of like the reverse card in Uno. It just changes direction because now you've essentially flipped the signs of everything. So when I do this, when I divide by a negative, well, 8 divided by -2 is, 8 divided by -4 is -2. And originally this was a less than sign, but this is now flipped the sign. Now this is greater than. So I have y is greater than -2. So my y values of -2 are right here. I want everything that is higher than -2, but I don't want to include -2. So this will be a dashed line. And I want values that are bigger than -2, so this would be shaded above. One possible solution here, y is greater than -2. Well, we could actually do the exact same solution as before, 3, 4. So 3, 1, 2, 3, 1, 2, 3, 4. That is also a possible solution. All right, so here's what I'd like for you guys to do. Mr. Parsons is going to go ahead and pause the video, and I would like for you guys just to do example 3. So take a minute. Go ahead and try to graph those, and don't worry about example 4 yet. That'll be for tomorrow. But what I'd like for you to do is go ahead and take a look at example 3. So Mr. Parsons, go ahead and pause the video, see what your students can do. All right, here are my 2 solutions. First off, for this one, I had a y-intercept of 3. My slope was down 1 over 3, down 1 over 3. And since that is a less than sign, it did not include equal, so we had a dashed line, and then I'm shaded below. Over here, this one is in point slope form. I went left 2, up 1, so that's where this came from, left 2, up 1. My slope is -2, so down 2 over 1, dashed line, shaded above.